Hey everybody, today we're going to talk about the fundamental theorem of algebra, what it is, what it does. Before we do that, real quick, let's just kind of take a little time out and talk about complex numbers. These are the numbers that look like this, a plus bi. Now, in a complex number, you have two things. You have real and you have, of course, imaginary. So any kind of combination of real and imaginary, whether you have them both or whether you have one, it's a complex number. So let's go through some examples, like 5. 5's real, so it's also complex. 2i. 2i is considered to be pure imaginary, but it's also complex. Then, of course, we can put them together. 1 minus 4i, 0. We can also throw in some radicals, negative I radical 3. We could have a fraction, like 1/2. So you kind of get the idea. Really, basically, complex number is pretty much everything. So the fundamental theorem of algebra says that you're going to have at least one answer that is a complex number, which makes sense. You're going to have at least one imaginary, you're going to have at least one real, maybe you have 2 imaginaries, but you're going to have at least one that's a complex number. Now, something else that we know is true is that the degree tells you exactly how many linear factors you're going to have or how many answers you'll have. Now, unfortunately, this includes all of them. Ones that are used twice, imaginaries, reals, it includes everything. So let's take a look at this. So you can see that the degree, which is the highest power, the degree is 4, which means we should have 4 answers. Okay, so the idea is that we find all 4 answers. So the first thing we do, of course, is set this thing equal to 0. Do not just add the 16 and take the 4th root because you won't get all the answers. This is difference of 2 squares. Any even power is a perfect square, so x squared and x squared. And 16, of course, is a perfect square, minus 4 plus 4. Now, the x squared minus 4 factors again, because that's the difference of 2 squares, x minus 2, x plus 2. And, of course, the one with the plus does not factor. Then you take each factor and set each factor equal to 0. X minus 2 equals 0. Add the 2. X plus 2 equals 0. Subtract the 2. And then we have x squared plus 4 equals 0. So we get x squared equals negative 4. And when you take the square root of this, you get plus and minus 2i. So here's 1, 2, 3, 4. So we did find all 4. So it's kind of nice to know how many answers you'll have long before you actually find them all. So for number 2, this is that kind of factoring that everyone loves. It has a degree 2, meaning the highest power is 2, so we should have 2 answers. Set this thing equal to 0, 6x squared plus 11x plus 4. And I'm going to slide and multiply. So we have x squared plus 11x plus 24, still equals 0. Now we need factors of 24, so we're going to multiply to get to 24, and then, of course, add or subtract to get to 11. So we have 1 times 24, 2 times 12, 3 times 8, because 3 plus 8 is 11. Everything is positive. We don't even have any negative signs in the problem. So we know x and x, and we already did all the numbers, so we know it's plus 3 and plus 8. Now remember, the key to this, since we messed it up by multiplying by 6, we have to turn around and divide by 6. Just the numbers. So this is x plus 1/2, and this is x plus, when we reduce this, 4/3. Now you don't have to do the bottoms up because we're solving it, so you can just say x plus 1/2 equals 0. So we get x equals negative 1/2. And we could say x plus 4/3 equals 0. So we get x equals negative 4/3. And just like we had predicted, we get 2 answers. So that's kind of a review of old type of factoring. Remember, any kind of factoring is an eligible question here. Here we have a degree of 3. So I have 3 zeros as well. You can see this is 4 terms. So we're going to group this. First of all, as you know, we're going to get it set equal to 0. So our grouping will be these two and then these two, sign included. So the first two have x squared in common. Leaves you with 3x plus 2. Now the idea is we sort of make sure it happens, that 3x plus 2 happens in the second group as well. No x's in commons here, so 6 and 4, so just the plus 2. They're both even, leaving you with 3x plus 2. So good, they match. Then, of course, the 3x plus 2, that comes out. Then in order from left to right, in that second group goes x squared plus 2. It still equals 0. So we have 3x plus 2 equals 0. Subtract the 2. And then, of course, we'll divide by 3. So we get x equals negative 2/3. Well, that's only one answer. We need 2 more. X squared plus 2 equals 0. So x squared equals negative 2. When you take the square root, first of all, you always get plus or minus. It's negative, so we're going to have an I, and we cannot simplify the 2, so it stays radical 2. This counts as 2 answers. Here's one more. We got all 3. Now, just for extremeness, check out number 4. Degree 5. 5 answers. Now remember, answers that get repeated, they count. However many times they repeat, if you have the same answer 3 times, that counts as 3 answers. So it doesn't mean we have 5 unique answers. It means we have 5 answers. So set this equal to 0, x to the 5th, 64x squared, sort of think about what we're doing here. They have an x squared in common. And that x to the 3rd plus 64, that's the sum of 2 cubes. So x squared stays here. And then we take the cube root, or what times itself 3 times gives you x to the 3rd. And then we take the cube root of 64, which is a 4. You just have to have this memorized. So then we square the x, that's this x. Multiply these two things together. Square the 4. Signs go same, opposite, always positive. Now we know that this thing right here does not factor again, so we're going to have to use quadratic formula. So we know that x squared equals 0, so x equals 0. This actually counts as 2. This is a double root. So there's 2 answers right there. X plus 4 equals 0. So there's 1 more answer. So we just need 2 more to get to our 5. So I'm going to use the quadratic formula in this. We already know it doesn't factor. So we know we get x equals the opposite of b plus or minus b squared minus 4 times a, which is 1, and c, which is 16. This looks like it might be imaginary, all over 2a. Underneath the radical, put this in the calculator, 16 minus 4 times 16, and you get negative 48. Now we need to break down 48. If you want to think of the largest perfect square that goes into 48, this is kind of a hard one. It's 16. So I'm going to break it down this way. 2 times 24. 24 is 2 times 12. 12 is 2 times 6, and 6 is 2 times 3. Lots of 2's. So there's a pair, and there's a pair. So this is 4 radical 3. But because it's imaginary, it's 4i, 4 plus or minus 4i radical 3. Then, of course, 2 goes evenly into all 3 of these. So the other 2 answers are 2 plus or minus 2i radical 3, right? Because this goes in 1, 2, 2. So this counts as 2 answers, 3, 4, 5. So let's kind of go back through this a little bit. Let's come up with some directions. So I have here create a flow chart or some other organizational scheme what's the process here? If you forget what you're doing, what are you looking at? So if you remember, the steps were, first thing we did was we set the equation equal to 0. Every time You basically get rid of the name, right? Sometimes the name's f of x, g of x, y. You just set it equal to 0. Then it seems like our next step was to just factor it. We had all kinds of different factoring. And if you can't factor it, then you're going to use the quadratic formula. Or maybe if you don't want to factor it, you can use the quadratic formula. And then, of course, after we factor it, you set the factors equal to 0, 1 by 1. And then, of course, you just simplify this. You just basically solve for x. Sometimes when we set the factors equal to 0, we also have to use the quadratic formula, like we just did. And don't forget, after you use the quadratic formula, you better simplify it. Meaning, take the square root of stuff, reduce your fractions, whatever it takes the arithmetic. So those are the steps to how to go through and solve this. What we're going to do now is something we've actually done before. We're going to go backwards. So from the zeros, we're going to write the factors, and then we're going to write the polynomial. So basically, if you have a 0, if a is a 0 of a polynomial, then, it's supposed to say then, x minus a is the factor. So we have the answer. So let's say we'll come over here to this table. This is basically your solution, your answer, your x-intercept, right? So we're calling it a 0. So if the answer is 3, then the factor is x minus 3. You always do the opposite. Here, if 0 is -4, this would be x plus 4. You don't have to put them in parentheses. I don't know why I'm doing that, actually. 0, well, that would just be x. 4i, x, opposite of that, minus 4i. Or -2i, it would be x plus 2i. Now, something else about imaginaries is that they always come in pairs. You don't just get one imaginary answer. You always get two, because that's how they undo each other. So if a plus bi is a 0, then a minus bi also must be a 0. This is called conjugate pairs, meaning don't take the opposite, just change the sign in the middle. All right, so we didn't change anything. We didn't change the sign on the beginning. We didn't change both signs. We only changed the sign in the middle. We'll go through that again here when we get to it. So the first thing we do is we switch all these zeros to factors. So they're telling you that the degree is 3, which is nice. So you know that when you're all done, you should have x to the third as your highest power. So if our 0 is 0, we know that's an x. If our 0 is 5, then the factor is x minus 5. And if our 0 is -7, then the factor is x plus 7. And then you just start multiplying. Up to you. Pick any two you want and multiply them together. I am going to leave the x out here and multiply these two things together first. So you get x squared, and then out here plus 7x, -5x, -35. Now if you'd rather make the box, then make the box. Combine like terms real quick, just because we'll have less to do. And then finally, distribute the x. So we get x to the third plus 2x squared minus 35x. Done. And x to the third is the degree, and you can see x to the third is the degree. So here's where our imaginaries come in. If 3i is a root, well, they come in pairs. So that means we also know x equals -3i. And so you could tell we didn't have enough, because it said that we should have 3 and we only had 2. So now we have 3, 1, 2, and 3. So sometimes you'll have to pay a little bit close attention. If you see an imaginary, make sure you have 2 of them. You can't just have 1 of them. So -2 is the answer, so this is x plus 2. 3i makes this x minus 3i, and -3i makes this x plus 3i. I would recommend multiplying the imaginary first, and always multiply them together. So let's leave this guy alone for a second. He's just going to hang out here. The imaginaries get rid of themselves, basically. So in your answer, you shouldn't have any i's. We don't have a thing called xi, so they shouldn't be there. So let's just go through and multiply this out. X squared all the way apart is plus 3ix, and then close together is a minus 3ix, and then the last two is a negative 9, and I times I is I squared. So these ix's should cancel, right? That's not a thing. If they don't cancel, then you have an arithmetic mistake somewhere. This x plus 2, he's still there. Then we have x squared. Now I squared is really negative 1. So we take out the I squared and we put in the negative 1. So now negative 9 times negative 1 is a positive 9. And now we have no more i's or I squareds. And we can just multiply these two things together. So we get finally x to the third plus 2x squared plus 9x plus 18. That is in standard form, meaning the highest power, and then it goes on down the line. And it is a degree 3. Now with this one, let's use our power of factoring to sort of reverse it. Plus or minus 1. So that means we know we have x minus 1 and x plus 1. Plus or minus 5. X minus 5, x plus 5. Well, this looks like the difference of two squares right here. If you were factoring, it'd be the difference of two squares. So just do first one squared minus second one squared. If you can factor it, it should be easy to multiply. So let's try that again. Again, difference of two squares here, x squared minus 25. Save yourself some time and see your factoring patterns and do it the opposite. If you don't see it, go ahead and use FOIL. You'll end up in the same spot. Now, of course, we have to multiply these two things together. So we would get x to the fourth minus 25x squared minus 1x squared plus 25. So remember, we're supposed to have a degree 4. Looks like we will. X to the fourth, these two get added together, minus 26x squared plus 25.